want to show you how we use differentials in calculating error propagation. That is, if you were to take a measurement of something and then use that measurement in a calculation, well, any error that you might have had in the measurement would cause an error in the calculated answer. So here's an example. I've got a cube and I measure the edge length as 50 centimeters. But I know my measuring stick is only good to, plus or minus 0.1 centimeters. So essentially I'm saying that x equals 50, but dx might be as much as, well, it's plus or minus 0.1, right? It might be big as plus 0.1, it might be as little as minus 0.1. So let's say it's plus or minus 0.1. Okay. Now I want to find the error in the volume calculation, and there's these other terms I've got to introduce as well. I want to find what's called the relative error and the percent error. So as I do these, we'll explain what these mean. Okay. So possible error in the volume calculation. Well, the thing is, to calculate the volume of this cube, I would just take my edge length and cube it, right? The volume is the edge length cubed. So the thing is, I may change that input by a little bit. Maybe it's not 50, maybe it's 50.1. So if I change the x value by a little bit, how is the volume going to change? Well, that's the whole notion of what these differentials tell you, that the change in the volume is the slope, or the derivative here, times the change in x, right? If you want to think of it as dv dx, so the derivative is 3x squared, then just multiply both sides by dx, and the change in the volume is the slope times the change in x. Okay. So looking at this thing now, I've got x is equal to 50, so plugging in, I've got 3 times 50 squared, and the dx is plus or minus 0.1. So I type that into my calculator, and I've got, turn it on, 50 squared times 3 times 0.1 is plus or minus 750 cubic centimeters. Now that may seem like a fairly big error, but how big is it really? This is where the notion of the relative error and the percent error come in. Before we do that, let me just reiterate what we did here. We had a particular measurement with a potential error in that measurement. Using that measurement, we're going to calculate something. We're going to calculate the volume. You want to know if there's error in the measured piece in this input, what is the error potentially in the output? Well, the change in the output is the slope times the change in the input. So I took a derivative, multiplied by dx. Okay. So now, notice that if I plug the 50 in at x equals 50, the volume is 50 cubed, and that's a fairly big number. If I can type it into my calculator, I'll find out. 50 cubed is actually equal to 125,000 cubic centimeters. So although it may seem like 750 cubic centimeters is a fairly big error, out of 125,000, it's not that big. In fact, what we call the relative error, let's see if I can, the relative error, some people think it's just being born into the wrong family, but what we mean in math is the relative error in the volume here is going to be dV divided by V. So we calculated dV as plus or minus 750, but the actual volume is 125,000. So if I take my 750 and I divide it by 125,000, I get a relative error of 0.006. Okay. Essentially a fraction of the total. The error was what fraction of the total volume. We then have the notion of a percent error. Well, the percent error is the relative error times 100%. So it's dV over V times 100%. And in this case, you got the 0.006 times 100% is 0.6%. So you got a 0.6% error potentially in your calculated volume because you had this 0.1 centimeter potential error in the measurement. Notice that there's the relative error in the volume. There's also, I could talk about the relative error in X, right? That relative error in X is dx over x, where v, it was dv over v. So the change in x divided by whatever x is, that's the relative change or the relative error. So in this case, it was 0.1 over 50. Right? What's 0.1 divided by 50? I ought to be able to do that in my head, but it's 0.002. So the percent error in x, let's make it look like a percent here, percent error in x is going to be that relative error, 0.002 times 100%. So the 100 moves it over and the percent stays on the end, so it's 0.2%. So for a 0.2% error in x, we ended up with a 0.6% error in the volume. Okay, so that error gets propagated. Error in x gives you an error in volume. Okay. There's a bunch of homework questions related where they give you, some error in your input. They ask for what the relative error or the percentage error in the output is. Anyway, you can give them a try.